Hi everyone, it's Miss Costa here, and in this video I'm going to be going through some potential topics for the calculator paper. Now this video is filmed way before the paper 1 is going to come out, so obviously it's not based on that, but it's just general revision if you're revising over the Easter holidays or before the paper 1 has been released. Okay, so to begin with, we've got this question which asks us to solve the simultaneous equations. Now, as you can see, one of them has an x squared in it, so that means that I'm dealing with a quadratic equation. So when I've got a quadratic and a linear equation, what I can do is substitute the linear equation into the quadratic. So first of all, what I want to do is rearrange the linear equation into the form y equals mx plus c. So let's rearrange this. Let's add 4x to both sides, and that would become y equals 4x plus 3. The reason I've done this is because then I can just substitute that in for anywhere I see a value of y. So if y equals 4x plus 3, in the quadratic equation, wherever I see a y, I can substitute 4x plus 3. So I'd say 4x plus 3 equals x squared plus 5x take 17. And now what I'm doing is working with only one variable, which is the x, so I can solve it and find out what the value is. So let's rearrange here. I'd take 3 from both sides, so 4x is x squared plus 5x take 20, and then I'm going to take 4x from both sides as well, so x squared plus x take 20 equals 0. So now what I want to do is factorise this to solve it like I would with any kind of quadratic. So the factors of 20, I've got 20 in 1 or 4 and 5 or 10 and 2, but I can see that I need to form a positive x. So what I'm going to do is choose 4 and 5. So how can they combine to make a positive x? One of them needs to be a negative because it's negative 20. So 5 take 4 gives me 1, and also 5 times negative 4 gives me negative 20, so they will be my factors. So x plus 5, x take 4 must equal 0, and therefore x must equal 4 and x must equal negative 5. So if I've got those two values, now with a quadratic simultaneous equations, you're going to have 4 solutions normally. So essentially what this is you have a graph, you have a quadratic that looks like that, and you have a linear equation, and the solutions are essentially the x and the y coordinates where they meet. So you're going to have an xy coordinate here and an xy coordinate here, so that's why I have 2 x values, and that's why I'm going to have 2 y values. So my solution is x is 4 and also x is negative 5. So let's roll about this working so we can make space and figure out what the y coordinate will be. Well, once I've figured out what the x coordinates are, I can just substitute into the easiest equation. So when x is 4, I'm going to substitute into this. So y take, now 4 times 4 is 16, y take 16 equals 3. If I add 16 to both sides, I'm left with y equals 19. So that is one of my solutions. So when x is 4, y equals 19. So therefore the coordinate would be 4, 19. And you can write your solutions in the forms of coordinates. And then let's try with the next one. When x is negative 5, over here, I'm going to substitute again. Y take 4 times negative 5 equals 3. So y take 4 times negative 5 is negative 20. And when you've got 2 negatives next to each other, they become positive. So y plus 20 equals 3. Therefore, let's rearrange. I'm going to subtract 20 from both sides, and I'm going to be left with 3 take 20 is negative 17. So when x is negative 5, y is negative 17. So the second coordinate, or the second solution, would be negative 5, negative 17. I'm just putting it in its coordinate form. And there would be your solution. So you can either represent them like this, where you just write them all out, or you could put them as coordinates. And that's how we solve quadratic simultaneous equations. Okay, so here I am being asked to write this equation in the form ax squared plus bx plus c equals 0. So essentially what they're asking me to do is rearrange that to write it in the quadratic form. So let's start by expanding what I've got. So x times 6x is going to give me 6x squared. X times negative 5 would be minus 5x. And that must equal 12. Well, I want to write it in the quadratic form, so let's just rearrange what we can. So I'm going to take 12 from both sides, and that would be 6x squared, take 5x, take 12 equals 0. So I thought it was going to ask me to solve it, but no, that's all it wants. It wants you to write this in the form 6x squared, take 5x. Okay, that's fine, where a would be 6, b would be negative 5, and c would be negative 12. And that's how we do that. So here I've got a algebraic fraction and I'm being asked to simplify it. Normally when you have algebraic fractions, you essentially are going to want to factorise them, and you're going to want to factorise the numerator and the denominator so they have a common bracket in common. So over here, and normally it's going to be a difference of 2 squares either on the numerator or denominator. So difference of 2 squares is where you've got x squared take away a square number. So I know that that can factorise to x plus 7, x take 7. And what about the numerator? Well, if I factorise out the x, that would be x bracket x plus 7. So let's write that as a fraction. So x brackets x plus 7 over x plus 7, x take 7. Now, whenever we have a fraction, if there's a term on the numerator that is the same as the term on the denominator, they can just cancel out. So this and this would cancel out to just leave me with 1, and I would be left with x over x take 7. So here I've got a triple bracket. So what I want to do when I have a triple bracket is pick 2 of the brackets and expand them like I normally would. So I'm going to choose 2x plus 4 squared. So I'm just going to expand that. So 2x times 2x would give me 4x squared. 2x times 4 is 8x. 2x times 4 is 8x. And 4 times 4 is 16. Simplify the terms in common, so that would be 4x squared plus 16x plus 16. Now what I want to do when I have expanded 2 of the brackets is draw myself a little grid. Obviously you can just expand it like normal, but this way just ensures you don't miss out any of the terms. So feel free to, if you're a pro at this and you just like doing the arrow method, then whatever you want. But the whole point is that I want to expand that expanded version of those double brackets and multiply it by the single bracket that's left over. So what I've done essentially is just multiply this out to get this, and then I'm multiplying it by this bracket here. So 4x squared times 3x would give me 12x cubed. 3 times 16 would be 48x squared. 3 times 16 again would be 48x. 4 times negative 3 is minus 12x squared. 3 times 16 is minus 48x. Minus 48. So now what I can do is see that these two, so with the diagonals, if you've written out the brackets in descending order of powers, then the diagonals are always going to simplify. So 48 take away 12, I can start by writing 12x cubed, and then 48 take 12 is 36x squared, and 48, oh, I think this is supposed to just say 48. So 48x take 48x is 0. So these two would cancel out and you'd be left with minus 48, which is what that should have said. That's just a typo. And that's how you show clearly. You could have also just written out the full thing, but having it in the grid would be enough, especially if you, but yeah, just for, fluency, write out the whole thing and then simplify it. Okay, so in this question, I am being asked to factorise a complicated looking quadratic. Now, because this is a calculator paper, I can use the quadratic formula. So the quadratic formula is for any quadratic that is expressed in the form ax squared plus bx plus c equals 0. And all I need to do is substitute it into this formula. So to solve, I would say x is negative b plus or minus the square root of b squared take 4ac over 2a. So just to make it a bit easier, I am going to colour each little variable in a separate colour. So a would be pink, b would be turquoise, so it's negative b and b squared, and then c will be darker, so c is over here. Okay, so every the coefficient of x squared is what your a would be. So over here I can see that a must be 6. The coefficient of x is going to be your b value, and b is just 1 because there is no coefficient, it's just x. And the c value is going to be negative 2. So I substitute these values into this equation here. So let's use a black pen again. So x must equal negative 1 plus or minus the root of, I'm just going to write this out like that, so plus or minus the root of 1 squared, take away 4 times by the value of a is 6 and the value of c is negative 2. And over here I do 2 times a, so 2 times 6. So what would that become? Let's simplify that. Well, x would be negative 1. And okay, the key thing with the quadratic formula is you're going to have 2 solutions, because first of all you have to find the solution of minus b plus everything and then minus b take everything. So let's just simplify it first and start with a plus. So that would be 1 squared. Negative 4 times 6 is negative 24, and negative 24 times by negative 2 is going to give you positive 48. So it's 1 squared plus 48 over 12. So let's simplify that even further. That would be negative 1 plus the square root of 49 over 12. So if you type that into your calculator, well, you could actually, because this is it's just a square number, so x would be negative 1 plus 7 over 12, which is 6 over 12, which is a half. So the first value of x is going to be a half. Then what you need to do is do exactly the same, except instead of adding, you're going to subtract. So over here, I'm just going to change that to subtract. So minus 1 take 7 is going to be negative 8. So you'd be left with negative 8 divided by 12. And that would leave you with minus 2 over 3. So the second value of x is minus 2 over 3. And that's how we use the quadratic formula. Essentially, we just substitute all of the values into the quadratic formula. So here we've got we're dealing with exponential graphs, and it tells me that a graph has equation y equals 5 to the power of x, and I need to find out the coordinates of the y-intercept. So the y-intercept is always where the graph, so because it's exponential, it's going to look like that, but the y-intercept is where the graph crosses the y-axis, and at the y-axis the value of x is always 0, so we can always work that out by substituting x equals 0 into the equation of the graph. So y equals 5 to the power of 0. Well, anything to the power of 0 is 1, so y must equal 1, and that's how we do that. So here I've got an arithmetic progression and I'm being asked to work out the nth term of this arithmetic progression. So the first step I take is work out the difference between each of the terms. So how do you get from 2 to -5? You subtract 7. From -5 to -12, it's the same thing, and so on. So I know that this sequence must be going up, well, in this case down, in the -7n times tables. So what I can do is write out the -7 times tables above my sequence to find out what the difference each time would be. So how do you get from -7 to 2? You add 9. How do you get from -14 to -5? You add 9. From -21 to -12, you add 9. So you can see that this is the -7 times tables, but it's 9 units higher. So it's basically been shifted by 9. So the nth term would be -7n plus 9. So if that's the nth term, I'm being asked if -49 is a term in the sequence. So what I can do is make my nth term, the rule of the sequence, equal to that term. And if it is a term, then it will solve to form a whole number. So let's solve this equation by subtracting 9 from both sides. So just solving it like any old algebraic equation. So that would be -7n equals -49. Take 9 would be -58. And then divide both sides by -7. So -58 divided by -7 is going to give me n is 8.28574. So I would have to say, sadly, no, it is not a term in the sequence. It's not a whole number. So -49 is the 8.285th term, but that doesn't exist. Terms have to be integers, whole numbers. So that's how I'd decide whether it's a term or not. If it was a term, n would be a whole number. Now here I have a geometric sequence. So unlike a geometric sequence, unlike an arithmetic sequence where the sequence increases by the same amount each time, here it's being either multiplied or divided. So I need to figure out what is the multiplier here. So how do I get from 5 to 15? Well, let's try this. I know that 5 times by 3 is 15. Does that work for my next terms as well? Yeah, 15 times 3 is 45, and same as here. So I know that each time I must be multiplying the previous term by 3. So I've been given the 1, 2, 3, 4, the first 5 terms, and I need to work out the 6th term. So what am I going to have to do? I'm going to have to multiply this by 3 to find out the 6th term, because that's the rule for the sequence. So 405 times by 3 gives me 1215. So that would be the 6th term. And I need to describe the rule of the sequence. So multiply the previous term by 3. And that's that. So here I have the nth term of a sequence. I've been given that. And I need to find the 5th term of the sequence. So in a sequence, n represents the term. Okay, so if I'm trying to find out the 5th term, n is going to be 5. So I just substitute that into the nth term that I've been given. So n squared divided by 2, I'm going to substitute n is 5. So that would become 5 squared over 2, which is 25 over 2, which is 12.5. So the 5th term of the sequence is 12.5. Now I'm being asked which term in the sequence is the first to have a value greater than 50. So I make my nth term, the rule of the sequence, equal to 50. And I need to work out which term is going to be greater than that. So let's solve this. So n squared, if I multiply both sides by 2 to figure out what the value of n must be, n squared is 100, and then I can do the square root of both sides. So n must be the square root of 100, which is 10. So that means that the 10th term, so n is 10, so let's see what happens if I substitute 10 into it. Well, 10 squared is 100, divided by 2 is 50. Now, it's asking me which term in the sequence is the first to have a value greater than 50. 50 is not greater than 50, so that must mean that the 11th term is the first term to have a value greater than. The 10th term has the exact value of 50, but the 11th term is the first to have a value greater than 50. Okay, so here I'm being asked to find the highest common factor of two numbers. Now, the best way to do that, well, there are lots of ways to do this. You could just list the numbers and find the first common multiple, or you could write each number as a product of its primes, which I like because it's a little bit more fun. So we find two numbers that multiply to make 72, and ideally one of them is a prime number. The easiest one to start with is 2, so 2 times 36. Just going to write the prime numbers up here. So whenever we get to a prime number, we circle it and that tree branch is extinguished. And then we go to the branch that isn't extinguished and we find the factors of that. So what are two factors of 36? I'm going to keep going with 2 because it's, you know, the smallest prime number and it's just easy to extinguish. Then what are the factors of 18? Well, 2 times 9 makes 18. And once again, I've got a 2, so I circle that. And then I've got 9. What are the factors of 9? 3 times 3, both of which are prime numbers, so I can write that here. So I'm just going to write this out. So 72 is 2 times by 2 times by 2 times by 3 times by 3. Now I'm going to do the same with 96. So I'll start with 2, and 2 times 48 gives me 96. Then the factors of 48, 2 times 24, and I extinguish the 2, so I circle it. And then the factors of 24, 2 times 12, and then the factors of 12, so 2 times 6, and then the factors of 6, so 2 times by 3. And then I've reached the end of my tree branch and I've got all of the factors. So 96 can be written as 2 times 2 times 2 times 2 times 2 times 3. Let's just check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 factors. Okay. So once I've done this, I have a few options again. The highest common factor essentially means the highest factor that fits into both of these numbers. So it has to be something that both of these that multiplies into both of these. So therefore it has to be less than the number of total factors. Now the best way to do this is to do it with a Venn diagram, but I'll show you another way as well. So these are the factors of 72, these are the factors of 96. So first what we want to do is find the common factors. So 2 and 2 is common, so that's once. So I'll write it out here and I'm also going to put it in the intersection. Then I've got 2 and 2 again, so I'm going to write it again. Then I've got 2 and 2 again, so I'm going to write another one, and that's it. Then I've got 3 and 3 that is common, and that's what would go in the intersection. So to find the highest common factor, I essentially find the common factors that they have out of their primes, and I multiply them all together. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So that's the highest common factor of 72 and 96. So either do a Venn diagram and put everything in there, and the highest common factor is all of the numbers in the intersection multiplied. Okay, now I need to find the lowest common multiple of 54 and 45. So a lowest common multiple, I can do that using the factor tree again as well, or I could just list all the numbers. So I could say, especially because this is a calculator paper, I could do 54 and the 45 times tables, and in my calculator keep adding them until I come with a common multiple, or I could do the factor tree again. So let's try this with 54. So 54, that would be 2 times by 27, circle the prime numbers, and then 27, I can do that by making 3 times by 9, circle the primes, and then 9 is 3 times by 3, circle the primes. So 54 can be written as 2 times by 3 times by 3 times by 3. And then 45, well, that can be expressed as 5 times by 9, circle the prime. And then 9 can be expressed as 3 times by 3, both of which are prime, so I circle those. So 45 is 5 times 3 times 3. Now the lowest common multiple is the first number that both of them multiply into, or essentially I can do it by once again creating a Venn diagram. Here I've got 54, here I've got 45. So what are the factors, the prime factors they have in common? So they've got why did it undo everything? They've got 3 in common, so that will go over here. They've got another 3 in common, so that will go over here. And then everything else is just unique to those. So 54 had 2 and 3 that would go over here, and 45 has 5. Now the lowest common multiple is everything that is in the Venn diagram. So the lowest common multiple is going to be 2 times by 3 times by 3 times by 3 times by 5. Or you just look at this over here and you list all of the factors. Any that repeat you only list once. So for instance, you'd say 2 times by 5 and then times by 3 once, and 3 once, and then times by 3. But I think the Venn diagram is just a little bit easier. So let's multiply them all together. This is a calculator paper. So 2 times 3 times 3 times 3 times 5 is 270. And that's how we do that. Okay, so here I'm being asked to work out the error interval. So an error interval is essentially your number expressed as an inequality telling you what the lowest possible value of it would be and the highest possible value of it be. So 9.43 is rounded to 2 decimal places and it becomes 9.43. So essentially what's the lowest possible thing it could have been and the highest possible thing it could have been in order to round to 9.43? Well, I look at 9.43 on a number line. And it could have been 9.42 or it could have been 9.44. So the maximum thing it could have been before it rounded up to 9.44 would be 9.435. And the lowest would be 9.425. Now, as an error interval, you obviously know that if it was 9.435, then it would round automatically to 9.44. So that's why we say an error interval, as it's a little bit more accurate than when I'm dealing with bounds. So I'd say 9.425 must be less than, oops, did it the wrong way around, less than or equal to x, because if it was 9.425 it would round up to here. It's only if it was less than this that it would round down, which must be less than 9.435, because if it was exactly 9.435 it would round up to 9.44. So that would be your error interval. You essentially find the midpoint between what it would have been rounded up and down to, and then the largest number it has to be less than, and the smallest number it can be equal to. And that's how we do that. Okay, so in this question I'm being asked to order decimals. So these are recurring decimals. So what I want to do is first of all just maybe set up a little what's it called? A little grid where I can compare everything. Okay. So that's my first one. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so my first one is going to be 0.131 recurring. Then you've got 0.13, and that's it. So everything here would be 0, 0. Then you've got 0.13 recurring. So just this bit would be recurring. Then you've got 0.131 recurring. And then finally, you've got 0.13 recurring. So everything here is recurring. So what I do is, first of all, I look at the first column. Everything is exactly the same, so that doesn't help me. So I'm going to look at the next column. Once again, everything is exactly the same, so that doesn't help me either. So we look at the third column and I look at the largest number. In this case, it's this. I've never used the highlighter before. It's this one here because 3 is the largest. So in ascending order, the first number would be 0.13 recurring. 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 0.13 recur and I've crossed that out. Can I use a different colour? Let's use yellow. This is exciting. I didn't know I could use a highlighter. Okay. Then I've got 3 digits here, 1, 2, 3, that are all 1. So I'm going to look at the next column over here, and I'm going to look for the largest number, which is this. So this is going to be my next number. So this one was 0.13 recurring. So I've done that one, and I've done this one. Then I look at the next 2. So I've got this one and this one that are equal. I look at the next column. This one is the largest one. So I'm going to say my third number is going to be 0.131 with a recurring. Fourth one, well, this is the next largest one in this column. So that would be 0.131 recurring. And finally, I'm going to be left with 0.13, and that's how I'd order these. Okay, so here I am trying to prove algebraically that a recurring decimal turns into a fraction. So what I do with questions like this is my decimal I just label as x. And then what I want to do is multiply it by a multiple of 10 so that I can get to a point where I can eliminate the recurring decimal part. So if I multiply it by 10, I'd be left with 10x is 4.44 recurring. So if I write that out, I know that 10x is 4.4 recurring and x is 0.4 recurring. I mean, I could put it like that if they prefer. And if I subtracted them, I get to subtract the recurring part, because 0.4 recurring, take 0.4 recurring gives you 0. So that's the whole point of doing this. 4 take 0 is 4, and 10 take away 1 is 9. So 9x is 4.0. So then I've got this equation, 9x equals 4. I can solve this equation by dividing both sides by 9. So I'd be left with x equals 4 over 9. And that's how I've proved that algebraically, sorry. Okay, so the product rule for counting. So Cara picks a new 4-digit PIN for her debit card. Each digit is a number from 0 to 9. So that means that there are 10 potential options, because it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. People always, this is a common kind of place people go wrong. So like, oh, it's 9, it can be 0 to 9, so it's 9 digits. So 10 potential options it could be. Cara can repeat digits if she likes. Her PIN starts with 8. The third digit is odd. Okay, so I know that the third digit is odd. So how many numbers between 0 and 9 are odd? I've got, why does it delete? I did not want it to delete. So you've got 1, 3, 5, 7 and 9. That's 1, 2, 3, 4, 5 potential numbers. So let's just write this out again. I'm not saying that the third digit is 5. I'm saying that there are 5 options. So for my first number, I have 8. So I only have 1 possible option. For my third digit, I have 5 possible options. So this represents options. Okay. So 1 option. Am I given any other information? No. So that means that my second and my third digit could be anything. So that means I've got 10 options and 10 options again. So what you're doing when you're doing something like this is you're saying, how many possible options do I have? And this is where I use the product rule. So instead of listing everything, and actually there is a story that when I was, anyway, a story about when I had locked my backpack's lock, and I spent about 3 hours going through every possible combination, and the final combination obviously was 999, which was what the code was, because it was a new lock, but it took me a very long time. So it's possible to break a lock, but it just takes a long time. And this will tell you how many combinations I actually went through. except it was a 3-digit one. But the point is that each option can be multiplied by each other option. So with the product rule, I just figure out how many possible options I have to work out the total combinations. So here I've got 1 can be combined with 10 different options, which can then be combined with 5 different options, and finally with 10. So I'd do 1 times 10 times 5 times 10, which is 500. So there must be 500 possible codes. So you figure out, to do these kinds of questions, you just figure out how many possible options there are and you multiply all of the possibilities. Okay, so here I have been given a compound shape. A compound shape is just a big shape made up of 2 smaller shapes that have been stuck together. So here I've got a triangle and a rectangle, and I need to find the perimeter of this shape. So that means I need to find this length here, and this length here, and this length here. Okay, well, I'm going to need to use trigonometry to find out this length here. So first of all, I want to find out this length here, which would also be the same as this length here. So let's draw out this triangle. That's 6. This is an angle of 43. And I am trying to work out this value here. So out of SOHCAHTOA, if I label my triangle first, actually, because with trigonometry, that's good practice. So this is your angle here. So then the opposite side is going to be this one here, because it's opposite your right angle. The hypotenuse is always the side opposite the right angle, and this is going to be my adjacent. So the 2 sides I'm working with is the adjacent, which I've been given, and the opposite, which I'm trying to find. So the trigonometric ratio that has the adjacent and the opposite, A and H, is cos. So I'd write out cos theta must equal adjacent over hypotenuse. That's just the trigonometric ratio. And I'm going to substitute all the values that I have. So theta, that just represents the angle. So I'm going to say cos 43 equals adjacent, which is 6 over x, the value I'm trying to find. I can rearrange that to give me x cos 43 equals 6. And therefore x must equal, if I divide both sides by cos 43, so divide both sides by cos 43, x is 6 over cos 43, and that gives me a value of 8.2039. So let's round that to 8.2. So this side here is 8.2 and this side here is 8.2. And now all I'm left with is figuring out, and obviously this one here is going to be 12 centimeters because it's sides of a rectangle, opposite sides are equal. So I am trying to figure out the hypotenuse of this triangle now, and I can just use Pythagoras to do that. So let's draw this triangle out. I've got 8.2 and 6, and Pythagoras' theorem is a squared plus b squared equals c squared. A and b are the 2 shorter sides, so 8.2 squared plus 6 squared must equal c squared, and I'm going to use the full value of what I wrote. So that was 8.203964767, just for completeness. So I'm going to square that, plus 6 squared gives me 103.3050379 equals c squared. So therefore c must be the square root of this. So I'm going to do square root of answer. C is 10.16390,859. So this length here is 10.16, let's say. Now to work out the perimeter, I'm going to do this. So let's rub out all our working. And I'm going to say 12 plus this length here, which is 8.2, plus 12 plus 6 plus 10.16. So plus 6 plus 12 plus 8.2 plus 12 is 48.36. So that's the perimeter of this compound shape. Okay, so finding out the surface area of a cylinder. So remember, surface area is like if you were wrapping up this item, where would the wrapping paper go? So if you thought about it, we'd have this area here, which is a circle, and then over here there'd be a base that also had a circle. Oh, why are those circles so non-circular? So let's try it again. There we go. The base and the top. So I need to work out the area of that. And then the cylinder part, if I unwrapped it, so if you cut up like a toilet roll and you unfolded it, it would just be a rectangle. And that would be, the height of it would be the height that is given here. And then the length of it would be, if you think about it, oh, I wish I had a toilet roll so I could show you, but the length of it would be the circumference of the circle, because the toilet roll has like that circular bit in there. So the length here would be the circumference of the circle. So how do you work out the circumference of a circle? Well, circumference is pi times by the diameter. So what's the diameter of this? Well, I know the radius is 5, so the diameter is going to be 10 centimeters. So what's the circumference of this particular circle? It's pi times by 10. So pi times by 10, I can just write that as 10 pi. So that's going to be this length, and that's 10 centimeters. So to work out the area of that rectangular part, I'm going to do 10 pi times by 10, which is just going to be 100 pi, which is, if I press the SD button, 314.1592654. So that's the area of the rectangular bit, so this bit here. And then I need to work out the area of the circular bits. So how do you work out the area of a circle? The area of a circle is pi times by radius squared. The radius is 5, so that would be 5 times by 5 squared, which is 25 pi, which is, if you type it into your calculator, 25 pi is 78.5398. So each of these circles are going to be 78.53981634, and you've got two of them, the base, the bottom and the top part. So 78.5398 times by 2 plus this. So your total surface area is going to be 314.15 plus 78.53 plus 78.53, which is plus 100 pi. And you could also have left it in terms of pi until the very end, so that would have given you in total 150 pi. So sometimes it's easier to work in pi. So that would have been 25 pi, that would have been 25 pi, and this would just have been left as 100 pi. But either way, 150 pi or 471.238898. I would recommend working with pi until the very end, because it just means you don't have to work with all these decimals, but whatever way works best for you. Okay, so here I have a question on circle theorems. I'm told that A, B, C and D are points on the circumference of the circle, and angle ACD over here is 47 degrees. I need to work out the size of angle ABD. Okay, so this is a simple angle subtended at the circumference by the same arc are equal. So what that means is, if I have a look at ACD, how is that formed? Well, let's draw the two lines that it's formed by. So angle ACD is formed by line A and line AC and line CD. And what's the arc that this is formed by? It's over here, so the arc AD. Okay, now let's have a look at angle ABD. That's formed by these two lines, so line AB and line BD, and that is also formed by this same arc. So that's what this circle theorem means. It means angles subtended at the circumference by the same arc are equal. So that angle here would be 47 degrees. And your reason would be angles subtended by the same arc are equal. Now, subtended just means formed, created. So when you're looking for these, you can trace it back to where the angles are formed. And if they're formed by the same arc, if that's where they originate, then that means that they're going to be equal. So here I have a sector of a circle, and I've been told the area of the sector. I haven't been given an angle, but I know what the area of the sector is. I also know that the radius is 6 centimeters. And I'm being asked to calculate the perimeter of the sector. So let's just write a couple of formulas out. I know the area of a circle is pi times radius squared. And to work out the area of the sector, I'm going to need to work out the area of the circle and multiply it by the fraction of the circle that it is. So whatever the angle is, once I work that out, over 360. So let's substitute what I know. Well, I know that the area is 18.849, so forth. So that must be pi times by 6 squared times by something over 360. So let's divide by what I can. So 18.849 equals 36 pi times by theta over 360. So I can divide the area by 36 pi, so 18.849, type all of it into your calculator, divided by 36 pi gives me a sixth. Okay, so a sixth must be equal to theta over 360. So if I then multiply both sides of the equation by 360, just to solve this, to find out what theta is, remember theta just represents the angle. So multiply both sides by 360, I'd be left with 60 degrees must be theta. So I figured out what the size of this angle is. So the size of the angle is 60 degrees. Now, how do I work out the perimeter of the sector? Well, to work out the perimeter of the sector, I'm going to need to do this, plus this, which means I need to find the arc length. So how do I find arc length? Well, what's the formula for the circumference of a circle? The circumference of a circle is pi times the diameter. So similarly, just like with the area, I'm going to need to work out the circumference of the whole circle and multiply it by the fraction of the circle that I'm dealing with. Now I know that this angle here is 60 degrees, and 60 over 360 simplifies to a sixth. So I'm just going to work out, to do the circumference, or actually just to work out the length of this arc here. So I'm going to change that to just length of arc. I'll work out the circumference of the whole circle, which is pi times the diameter. So if the radius is 6, the diameter would be 12, because the diameter is double the radius. So pi times 12 times by a sixth. I could have typed in 60 over 360, but I know that simplifies to a sixth. So the length of the arc is going to be 12 pi over 6, which is 12 pi divided by 6 is 2 pi, which is 6.283185,307. So this arc length here is going to be 6.283 and so forth. So the perimeter of the sector is going to be what I've just worked out, 6.28 plus 6 plus 6, because it's the perimeter all the way around, not just the arc length, it's that plus that plus that. So that would give me 18.28318531, and it says give your answer to 3 significant figures, so that would be 18.3. So 3 significant figures, circle the third significant figure and look next door. And that's how I'd do that. Quite a tricky one because it involves quite a lot of things, but hopefully that makes sense. Okay, so in this question I am dealing with polygons. A polygon is just a many-sided shape, and I'm told that the polygon has 15 sides and I need to work out the size of an interior angle. So just a quick recap, let's see what the pattern is with polygons. So over here, you know that a triangle has 3 angles that must sum to 180 degrees. So a 3-sided shape, each angle must be 60 degrees. Now, regular means that each angle on each side is exactly the same. So that's why I do 180 divided by 3. There are 3 angles, so it's 60 degrees. Over here, what happens? Well, it's a 4-sided shape, so that means there are 2 triangles that would fit into it. So I do 2 times by 360. Sorry, 2 times 180, which is 360 degrees. So one interior angle would be 360 divided by 4, which is 90 degrees. Over here, I've got a pentagon. So I split my shape up into triangles. And remember, to draw the triangles, you always start from one point. And you draw a line to each vertice. So that means there'd be 3 angles here, and 3 triangles, sorry, and in each triangle you have 180 degrees. So you do 3 times 180, which is 540 degrees. And so therefore each interior angle is going to be 540 divided by 5, because there are 5 angles, which is 108 degrees. So hopefully you remember this. If not, then this is a brief little recap. So the formula is however many sides there are, so n is the number of sides of a polygon. There are always, so here it was a 3-sided shape, and there were there was 1 triangle. So here it's a 4-sided shape, and there are 2 triangles. And here it's a 5-sided shape, and it has 3 triangles in it. So however many sides a polygon has, it's always going to have 2 less triangles that fit into that. And if we know how many triangles there are in a polygon, we multiply that by 180 to figure out what the angles must sum to inside of it. So n take 2 times by 180 tells you the sum of the interior angles of any polygon. So in this case, what we'd need to do is substitute that. So this was just a little recap. You can obviously just remember the formula, but it's good to know why and how things happen. So the number of sides is 15. So 15 take 2. That means I'd be able to fit 13 triangles inside this 15-sided shape. So 13 times by 180 gives me 13 times 180 is 2,340. So that is the sum of the interior angles. So what all of the interior angles add together to make. And I need to work out the size of one interior angle. So I'm going to have to do 2,340 divided by 15, because if it has 15 sides, it's going to have 15 angles. So divide that by 15 is 156 degrees. And that's the size of one of those interior angles. So here I've got some vector arithmetic. So vectors can be expressed as column vectors, where the top part represents the movement along the x-axis and the bottom part represents the movement along the y-axis. So when I am manipulating these, I can just multiply everything inside it. So if f is -3 along the x-axis and 4 along the y-axis, 3f is going to be 3 lots of each coordinate, each movement. So 3f is going to be -3 times 3 is -9, and 4 times 3 is 12. So that's 3f. And then 2g is going to be double this. So double -2 is -4, and double 5 is 10. So I've just doubled that. And now what I need to do is subtract them. So just like with normal arithmetic, I'm just going to work with the x values first. So -9 minus -4. So that would become -9 plus 4, because when there's 2 negative signs next to each other, they turn into a plus. So -9 plus 4 is -5. And then you've got 12 take 10, which is 2. So that's how I'd work that out. And then I've got 2g take away f. So once again, I'm going to double g. So that would be -4, 10, which I've actually already worked out, so I didn't need to do that. Take f, which is just -3. 4. And I just subtract them like I would any normal number. So -4 take -3 would become -4 plus 3, which is -1. 10 take 4 is 6. And that's all I do for vector arithmetic. I just add along the top, add along the bottom, or subtract, and that's that. Okay, so here I've got a bearing question. So I'm told that the bearing of a ship from a lighthouse is 72 degrees, or 072. So the bearing of a ship from a lighthouse. So I'm gonna just draw my little lighthouse here. Remember, the rules of bearings are you always start from where it says from. So I'm gonna start from the lighthouse. Vectors are always, you always measure them from due north. So you draw a north line going up, and you always measure them clockwise until you reach your line. So 72 degrees is going to be roughly there. So I can just draw a little diagram helping me figure out what's going on. So that angle here is going to be 72 degrees, and that is where my ship is going to be roughly. So I need to calculate the bearing of the lighthouse from the ship. So remember, you always start your bearings from where it says from. So the ship is over here. You always start from due north, and you always go clockwise. So you're going to go around until you reach the line. So this is the angle that I need to work out for the bearing. Now, what I can use with bearings, because I've got two north signs, that means I've got parallel lines, because they're both going to be exactly the same. So what I can do is use the rule of co-interior angles. So co-interior angles sum to 180 degrees. So if I do 180, take 72, that would give me 108 degrees over here. So that is this angle here. And over here I've got a point. So I know the angles at a point sum to 360. So I could just do 360, take 108 to figure out that angle there. Sorry, my nose is so itchy. 360 take away 108 is 252 degrees. So that's this angle here, which is the bearing of the lighthouse from the ship. So this is the ship. I start from due north, go all the way around until I reach a line, and that is the bearing. So 252 degrees. Okay, so here I've got a ratio problem solving. So Matt and Lucy have a total of 200 marbles. The ratio of the number of marbles Matt has to how many Lucy has is 6 to 4. So it's 1, 2, 3, 4, 5, 6 is what Matt has. And Lucy has 4 parts. So let's do it in a different colour. Lucy is 1, 2, 3, 4 parts, and all of that must sum to 200 marbles. So if I did 200 divided by 10, that's 20. So each of these little parts must represent 20. So therefore, Matt must have 60 times 20, which is 120, and Lucy must have 80. Now, Matt gives Lucy some marbles. The ratio of the number of marbles Matt now has to Lucy is now 9 to 11. Okay, work out how many marbles Matt gave to Lucy. So once again, we still know that there are 200 marbles. So if we did 200 divided by 20 now, that would give me 10. So one part must be worth 10 marbles. To visually represent this, Matt has 1, 2, 3, 4, 5, 6, 7, 8, 9 parts, and Lucy has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts. So if each part is worth 10, that must mean that Matt has, why did I decide to do this? 10, 10, 10, 10, 10. Matt has 90. And Lucy has 110. So how many marbles did Matt give Lucy? Well, if he had 120 to begin with, and he now has 90, he must have given her 30 marbles. And that's how we'd work that out. So it always helps to kind of like draw out what's actually going on. Okay, so another speed question. So Gordon drives 180 miles in 7 hours. He drives the first 30 miles at an average speed of 34 miles per hour. So let's figure out how much that must have taken him. So we know that speed equals distance over time. So to rearrange that formula to work out time, I would say that time is distance over speed. So I know that the distance he travelled was 30 and the speed was 34. So what would that be? Well, 30 divided by 34. Oh, that's an ugly number. Let's just keep it as 15/17 of an hour. Okay, 15/17 of an hour. So I need to work out the speed for the rest of the journey. So I know that he has, if he's travelled 30 miles, he has 150 miles left. And he's travelled, he travels the whole thing in 7 hours, but he's already travelled 15/17 of an hour. So he has 6 2/17 of an hour left to go. So I need to work out his average speed for the rest of that. So speed equals distance, 150, divided by time. So 6 7 take 15/17. Oh, 7 take 15/17. Why is that coming up as syntax error? Okay, so that would be, this is ugly, but 6.117640. So you just save that as an answer in your calculator and you do 150 divided by answer. So 150 divided by answer gives you 24.52, rounded to 2 decimal places, miles per hour. So quite a slow driver. He must have been driving some country roads there. Okay, so here I've got a population density question. So the population density, essentially all it means is how squished people are in a population per kilometre squared. So somewhere like Iceland, it's going to have a low population density because people aren't, there's not very many people for the amount of land that there is. Somewhere like, or England is going to have a much higher population density because there's a lot of people on this small island. So Mexico covers an area of 1,943,950 kilometres squared, and it has a population of 132,646,632 people. And I need to calculate the population density. So the formula for population density is the total population divided by the total land area. So quite a nice question. All I have to do is the population, which is 132,646,632, divided by 1,943,950. So just plug that into your calculator, which is 132,646,632 divided by 1,943,950 equals 68.2356. So I can just round, it doesn't tell me, but I'm not going to have 0.23 of a person, am I? So I'll just round that to 68 people per kilometre squared. So for every kilometre in area, every square kilometre in Mexico, there's around 68 people. And that's population density. So here I have a percentage change question. So I know that a puppy weighed 1.5 kilograms when it was born, and 6 weeks later its weight was 4.2 kilograms. So it obviously grew like puppies do. And I need to work out the percentage increase. So to work out percentage change, I do the percentage difference of the new weight and the original weight divided by the original weight or number times by 100. So in this case, I'm going to do 4.2, take 1.5 over 1.5 times 100. And 4.2, take 1.5 is 2.7. 2.7 divided by 1.5 times by 100 is 180. So the percentage increase is 180%. So it's essentially, if it doubled, it would be a 100% increase, which would be 3 kilograms, but it's 180%. Okay, so here I have a question that has a lot of information, and generally when I've got a question like this, I'm going to either want to do a Venn diagram or a two-way table. So let's do a two-way table. So at university, 150 students study maths. As part of their first year, they can choose an optional subject for one of their modules. Some students choose philosophy, some choose economics, and the rest choose physics. So I'm going to have 3 options, 1, 2, 3. Philosophy, economics, and physics. And my final column is going to be the total column. Then I'm going to have 3 columns here because the way they've separated them is into female and male students. So over here I'm going to have female students, and over here I'm going to have male students. And here is going to be my total column. So what information do I know? Well, I know that in total I have 150 students. I know 80 of the students are female. So in my female column total, that's going to be 80. These 2 columns must sum to make 150. So that is going to be 70. I know that 13 of the 20 students who study philosophy, so along my philosophy column, I know that must be 20 in total, and 13 of those people are male. So if that must sum to 20, that must mean 7 are female. And then the other piece of information is 54 people study economics. So over here, that would be 54. And what other information is 52 females study physics. So that's the information that I've been given here. Now I need to work out the number of males who study economics. So this is my target area here. So let's see what I can work out. Well, this is a little missing part. So I know there are 80 females in total. 52 of them study physics and 7 study philosophy. So if I subtract that, I'm left with 21. And I know that in total, there are 54 people that study economics. So 54, take 21, is going to be 33. So therefore, 33 males study economics. Okay, so here I am being asked to draw a histogram. Now, the key thing about a histogram is that the y-axis is always going to be the frequency or density. I wish that wasn't such a thick pen. Let's try that again. So that's going to be the frequency density. And then your x-axis is going to be your continuous data. So in this case, it's going to be the weight. Now, the way you draw a histogram is you draw a little bar, and the bar represents the frequency. So essentially, the frequency is the frequency density times by the weight. So let's see what we can do here. So I know that the weight from 2 to 8, so from here to here, I've got a class width of 6. and a frequency of 270. So to find the frequency density from a histogram, what I'd do is I'd do the frequency divided by the class width. So in this case, the frequency is 270. So I do 270 divided by 6. So 270 divided by 6 is 45. So I know that the height needs to be 45. And essentially, in a histogram, the area represents the frequency. Oh, why did it undo it? So this represents 270 people. I do the same thing for my next one. So the class width from 8 to 12, that's the class width of 4, and the frequency is 380. So I'm going to do 380 divided by 4. 380 divided by 4 is 95. So over here, I'm going to go up to 95. And this is a really badly drawn histogram. You're obviously going to do it much neater on yours. So 95. And that represents 380 people. Next, I've got a class width of 12 to 20 is 8. So I'm going to do, why has it gone so big? I'm going to do 320 divided by 8. And 320 divided by 8 is 40. So the frequency density is 40. And the class width is 8. So it's going to go all the way up to 20. And that represents 320 dogs. And the last bit, my class width is 10. So I go from 20 to 30 and I do 90 divided by 10, which is 9. So that means my frequency density is 9. Why does it always undo it? So 9 is going to be just under, nope, that's 8. So just under here and going all the way to 30. And that represents 90 people. So that's how I do a histogram. So essentially this thing here, these little things, the area of that box is the frequency. So here the frequency density is 9 and 9 times by 10 gives me 90. Here the frequency density is 40 and 40 times by the class width, which is 8, gives me 320. So 40 times 8 is 320. Here I did 9 times 10, which is 90. So that's how you'd read a histogram. So the frequency is the amount of people, and that is represented by the area of the bar chart or the bar that you've drawn. Frequency density is what goes along the y-axis, and the continuous data goes along the x-axis. Okay, so here I have a box plot. I am told the box plot shows information about the weights of some sloths in Costa Rica. The smallest sloth weighed 3 kilograms and the largest sloth weighed 7.5. So it hasn't told you what anything is, but it's told you the smallest and the largest, and they are like the whiskers of the box plot. So the smallest and the largest are where the box plot starts and ends. So this here must be 3. And this here must be 7.5. So I can use that to figure out what the intervals are. So let's see. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the difference between 3 and 7.5 is 4.5. And 9 divided by 4.5 is 2. So that must mean that each box represents 2. So I can start labeling that as what did I just do? I was supposed to do 4.5 divided by 9, sorry. 4.5 divided by 9, because the distance is 4.5 and there are 9 squares. So each little square must be 0.5. So that would be 3.5 here, 4, 4.5, 5, 5.5, 6, 6.5 and 7. So you work out what the distance is. Now we need to find what the median weight of a sloth is. The median is always represented by like the line that's in the middle of the box plot. So the median is over here. If that's 5.5, that would be 5.6, 7, 8, 9. So that would be 5.9. What's the interquartile range? So the interquartile range is the upper quartile. Take away the lower quartile. Now the upper quartile is where the box part ends at the top. So this would be 6.6, and the lower quartile is the lower part of the box. So that is exactly 4.5. So the interquartile range would be 6.6, take 4.5. And 6.6 take 4.5 is 2.1. Now, one of the sloths weighed 6.6 kilograms. What percentage of sloths weigh less than this? Well, 6.6 kilograms is the upper quartile, and the upper quartile represents 75% of the data, 3/4 of the data. So that must mean that 75% of the sloths weigh less than this, because it's exactly on where the upper quartile is. Okay, so in this question, I am showing the graph of a function, and I am being asked to transform this function. So when I deal with things like this, when I deal with graph transformations, there are two really important things to bear in mind. I can transform the function, change the function by doing things to the x coordinate or the y coordinate. So if it's inside the bracket, then I am changing, manipulating the x coordinate, and whatever is inside the bracket is the inverse of what I do. And if it's outside of the bracket, then that affects the y coordinate, and I just do what it says on the box. So with this, what I'm doing is I'm going to move this graph along the x-axis. I do the inverse, so it's x plus 4, so I'm going to do x take 4, and I'm going to move them 3 down along the y-axis. So pick a coordinate. So over here I've got 2, 2. I'm going to go 4 along, so 1, 2, 3, 4, and then 3 down, so 1, 2, 3. So that is where that part of the graph would be. I can do that with each little part. So maybe I'll do, oh, what happened there? Maybe I'll do this part here. So I go 1, 2, 3, 4 along, 1, 2, 3 down, and I can start drawing it. Let's do the next part over here. So I go 1, 2, 3, 4 along, 1, 2, 3 down, and I can start actually just drawing it out. So I can keep going, or I can draw it out, up to you. So I go 1, 2, 3, 4, 1, 2, 3. So I'll join that up there, and then I know it goes across too. So that's how I do that. So essentially graph transformations, if the function is being transformed here inside the bracket, you do the inverse of what it tells you to do. So it's saying plus 4, you're going to minus 4 along the x. Inside the bracket it affects the x coordinate, and outside affects the y coordinate. So they're the key things you need to know. Okay, so the final question is iterative processes. So I need to use the iteration formula to find the values of x1, x2 and x3. All iteration means is I'm plugging something in to find a value, and then I use that value to work out the next value. So I'm getting more and more accurate with each time I plug it in. So x0 is essentially my first term. So x1 is going to be 3 lots of xn, so that's the original, which in this case is 5, plus 4. So n plus 1 just means like the next term, and that is 1 less than that. So if I'm working out x1, 3xn is going to be x0. So x0 is 5, so that's why I plug in 5 here. So x1 is going to be the square root of 3 times 5 plus 4, so 15 plus 4, which is the square root of 19. So I'm just going to write this here. x1 is the square root of 19, which is 4.358898944. Okay, then I'm going to work out x2 by plugging exactly that in. So I'm going to say 3 times by, and actually I could keep it as a square root of 19 just to so I don't have to type out that long decimal, plus 4. So that would be, let's work out what the 3 times the square root of 19 is, plus 4, and then I just do the square root of the answer. So that would be 4.132396016. So x2 is going to be 4.132396016, And finally, I do x3. So I'm going to do the square root of 3 times by this, my previous answer, 4.13, blah, 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 plus 4. So now I could even just plug it in, square root of brackets, 3 times answer, close brackets, plus 4 gives me 4.04934415. And there we go. I have worked out x1, x2 and x3. And that's that. Okay, so that's the end of this. I've just made like 3 videos of revision, all of them in kind of like different topics. Obviously anything can come up. We don't know, but if there's anything you need a little bit more recap on, or anything that needs to be explained in more depth, or any more questions, just let me know, drop a comment and I'll make a video for you. So good luck.